Hello, everyone. Thank you guys for joining us on the Maintainer Summit. So our session today is about a workshop on hands-on chaos engineering. We would want it to be very interactive, so we'd want you guys to follow along. We have a lot of QR codes for you to scan the repos and clone it, and then also download the binaries and everything, so we all can get started together. We have 4 speakers. We have Shubham, Saranya, me, and Namkyu. I'll just allow them to introduce themselves.
Yeah, hi, I am Shubham Chaudhary, a maintainer of LitmusChaos and a senior software engineer at Harness.
Hi everyone, this is Saranya, and I'm also one of the maintainers of LitmusChaos and senior software engineer at Harness. Thank you.
Hi, this is Namkyu Park. I'm one of the LitmusChaos maintainer and also a CNCF ambassador. Thank you.
And lastly, I'm Sayan. I'm also one of the maintainers, and I'm also a community manager for Litmus and Harness. So majorly me and Shubham will be covering the theory and the workshop part of it, and it's very less theory, don't worry. And Namkyu and Saranya will be helping out troubleshoot or in case you guys get stuck on anything. So they'll be around helping everyone. So what does the agenda look like? We start with introduction to chaos engineering and Litmus, which is very short. Then we move on to the graduation updates that we are pursuing for Litmus. And then we move on to the Litmus SDK, which is the main SDK will be used to create and bootstrap your chaos experiments. And then finally, we'll see how you can create these experiments, push them to ChaosHub and run these experiments. So just a quick shout out to the just a quick prerequisites before we get started. It'll be great if you guys can install Golang if you don't have it already. There's the second link, which is the Litmus Go, which is the repository which we'll be using and cloning, which has the Litmus SDK basically. And the third one is a README with all the step-by-step guides. So you can just quickly scan these 2 QR codes, and it should be you'll be good to get started. There's also the hosted chaos center, which we have already hosted for you guys. So if you want to install Litmus in your system fresh, you can do that. There's a dev wiki guide as well, but in case you don't want to, there's also the hosted chaos center with this link, which is quite bad. So we have the QR code. You can go there. The credentials are admin and root @123. So Litmus is already hosted there. You guys can just simply scan it, play around with the portal, and when we do the workshop, you guys can follow along. So you can take a quick snapshot or just download it now, it's fine. So we have the QR as well when I talk about chaos engineering, so you guys can still do the scanning. But yeah, just starting with what is chaos engineering, it is a very in simple terms, it is a practice of injecting chaos in your system. So to prove and to see how resilient your systems are. So that is, in very short, very basic, what chaos engineering is. And this is taken from the principles of chaos.org, which is the holy grail of chaos engineering. It was first published by Netflix, and it has still been there and is the major source of all knowledge on chaos engineering. Next, what are the few steps on how you should practice chaos engineering? You should first start with the system to test. You should first select which system you want to test, identify them, then you select which chaos experiments you want to run on top of them. So you would first find some vulnerabilities or some weaknesses in your system, and based on that, you would select certain experiments to perform to mitigate those vulnerabilities. So that is step 2. The third is you run those set of experiments on the targeted system that you have identified. And step 4 is you observe the result. You observe what you found as part of the experiment, and then the 5th and the last one is you use those learnings to make your system better. Now talking about the product, which is Litmus, it is open source. It is a cross-cloud, cloud-native chaos engineering solution, which is a CNCF sandbox, CNCF incubating project right now, and it is very flexible in terms of plugging with other open source products, or it supports more than 50 worlds as of today, and also it has support for GitOps and a lot of other things like multiple chaos planes and control plane and execution plane. So it's very flexible to inject chaos into it because it's like broken down into multiple pieces. And here's the journey of Litmus until today. So we started off in September 2019 when we made the repository public for the first time. Then we joined Sandbox on June of 2020, and then We shifted to CNCF-incubating on January 2022, and now we are moving to graduation. Yeah, so a few updates on what we have been doing to reach the graduation milestone are these. So we have completed the tech docs analysis very recently. Huge thanks to Dave and Nate for helping with that. We have also completed the security audit, which was done by 7A Security. So really a great shout out to them for helping us with the security audits. We also have the LitmusChaos Con, which is the flagship event of Litmus, which happens on the September of every year. And this was the first year which we sort of inaugurated that conference. So we are really very proud of that. And the next one will happen on 2025 September. So we're really looking forward to you guys joining there. We also have the mentorships, which we do as part of GSOC, Outreachy, LFX. So we are very active with GSOC and LFX at the moment, and we participate in all the terms. So the next one is coming right up on January, which is the term 1. I believe it's the term 1 on January. So feel free to join them. If you're a new open source contributor, you can join us, and we'll mentor you to contribute better. And we'll also highlight some of the recent contributions done on Litmus, which are adding distributed tracing, which was done by Namkyu. We'll also talk about some other contributions like the upgrade agent, which was made more seamless, which was also part of 2.x, but then we removed it. And now it's back again on 3.x, which helps you make a smoother transition and changes to your schema, your DB migrations, etc. We also have updates on CRUD operations that were done as part of the resilience probes. And finally, there's a couple of more updates on, I think we are missing one. Yeah, multiple project owners, which was also added as part of Litmus 3.x. So yeah, a couple of great contributions we have as part of Litmus 3.x. But yeah, that's just some of the contributions that we want to highlight. And moving forward, there's a session tomorrow as well. There's a lightning talk on LitmusChaos evolution. There will be a 5-minute talks on what security enhancements we have been doing and things like that, which the QR code you can scan and RSVP for that. Next up, we have the ChaosHub, which is the central repository where we host all our faults. So we currently have a list of 51 plus faults at the moment, which are not just limited to specific, like very generic faults, but also vendor-specific faults and also application-specific faults like K6, Spring, etc., which we'll be using as part of the workshop. So now I'll hand it over to Shubham, who will take you through the SDK, what it is, and also how you can use it for the workshop.
It's on. Yeah. Mic testing. Yeah. So we have a Litmus SDK where you can generate your own chaos experiments. And once the experiment is created, you can generate a chart and you can host into the ChaosHub. So ChaosHub is a marketplace where we can list the charts. So as we see in the previous slide, we have 51 plus experiments. So you can host your charts into the ChaosHub, and then you can use, while you have constructed the experiment, then you can choose the charts from the ChaosHub and you can run the experiments. So as part of a Litmus SDK, we have attribute.yml file where you can where the experiment metadata is present. So based on that experiment metadata, we can generate the experiment which support the multiple types. So it can be a vendor specific like AWS, GCP, VMware, Azure, and it can be in the Kubernetes it can be a exec based or helper based models. And once the experiment is created, we can generate a chart as well. In chart, it is chaos engine and chaos experiment, which are the custom resources. And we have a CSV, which contain the metadata of the experiment. So based on this CSV file, we show things in the ChaosHub. And once we create an experiment, so it contains our placeholders. So in the placeholders, there are a steady state check, which you can add in a pre-chaos and post-chaos based on the fault type. and there is a chaos injection and chaos revert logic. There, based on your scenario, you can update the chaos injection and revert step as well. So this is the repo link. So you can scan the QR code, and here we have the user guide where we mention all the steps, and this is our hosted chaos center. This is the where we have a chaos center. You can use this chaos center to run those faults. So there are the credentials. So username is admin and password is root@123.
One more thing I'd like to add. If you face any problems while you are following along, just raise your hands or anything, and we'll just come and help you out.
Yeah. So this is the README where we have all the steps. So the prerequisite is Go should be installed in your system. And then next step is we have a Litmus Go repository where we are maintaining the templates and the Litmus SDK. So you need to clone this repository. And then in the Litmus Go /contribute/developer guide, you can move to this directory where the Litmus SDK is present. So you can follow me. I will run all these steps. Okay, yeah. So this is the Litmus Go repository which I already cloned. So we can move to the contribute developer guide directory. And here we have a Litmus SDK. So we can follow these steps. So first, we can generate a binary based on our OS and architecture. So I'm just generating a binary for Litmus SDK. So local binary is generated. Now we have a attribute.yaml file. So here we have a attribute.yaml.sample file. So we can create a attribute.yaml file based on this. In the ID, you can see attribute.yaml file is there, which contain the metadata of the new fault which you wanted to create. So based on our fault type, we can change the data here. So it is the name of the fault. So let's say I'm creating a pod CPU stress fault. And the version, it's initial version, so I'm just using 0.1.0. Here we can give the category. So it's, let's say, Kubernetes. And the other URL in the description you can provide. So I'm right now using all the default values. And if you wanted to, these are the keywords. Based on these keywords, you can list these on the ChaosHub. So I'm using the default keywords and everything. And this is the permission. This is the RBAC permissions required for the Kubernetes. And then here the maintainer details and provider and other references you can provide. So I'm using all defaults values. And the next step is, once you have populated all the values in the attribute.yaml file, you can generate a experiment based on this. So here is a -t command which support exec, helper, and AWS, VMware, Azure, and GCP. So in exec-based model, we are from the experiment pod, we are exec into the target pod, and then we are running some chaos inject and revert command. In a helper-based mode, we are creating a helper pod, and without exec into the target application, we are injecting chaos from the outside without actually exec into it. And we have a cloud-specific like AWS, VMware, Azure, GCP as well. So if you want to construct any fault into these platforms, then also you can construct. So I'm using a exec-based mode here. So the experiment is created. So once we create once the experiment is created, so it the category is Kubernetes. Inside the category, the pod CPU stress directory is created, which is the name of the experiment. And here you will find the experiment directory. So this experiment directory contains the whole life cycle of the experiment. So it, as we saw in the previous slide, it's have a steady state check, chaos inject, and revert steps. So here I have put the placeholders. So based on your application, you can add a pre-chaos steps. So right now it's by default because it is a pod specific fault. So we already have a health check for the pod, which is already there. So if you wanted to add additional steady state check, then you can add. But I'm keeping the default values here. And same is true for the post chaos as well. In the post chaos also, we have a placeholders. You can provide a steady state validations here. So, and the default AUT check is there. And then inside the chaos lib directory, we will have a pod CPU stress. So this chaos lib contains the business logic of the fault. So this is exec base. In exec base, you can provide the chaos inject and revert command, and it will exec inside the target application. It will run those inject command, and after the chaos duration is over, it will revert that. So it contains all the business logic here. And if you wanted to modify anything, then you can change the code here. So I'm using the default experiment here. And once the experiment is created, and if whatever the tuning we wanted to do, once we are done with the tuning, we can create an image of this experiment. So we can directly run the Docker command, and we can build the Docker image from here. And then we can generate a chart, which we can upload to the hub. To generate a chart, we can use this command. So it's generated the chart. So we can see the chart in the same directory, experiments, Kubernetes, name of experiment, and here the charts are there. So it contains engine and experiments, which are the custom resources. We have a CSV file for the fault. Also for the category, also we have a CSV file and a package.yaml. And also the RBAC also we have, based on the permission we have provided in the attribute.yaml file. So once we have all these charts, then we have a chaos charts repo. Based on this chaos chart repo, we are creating a ChaosHub. So if you can see, this is our default ChaosHub, which have 51 faults, and all the data populated here is based on the chaos chart repo itself. So you can clone the chaos charts repo, or you can create your own repo. It should follow a specific format. So let's say this is my chaos chart repo, which I created for this experiment. So it contains a name of category. For category, we should have a package.yaml file and the CSV file, which is already created using SDK here. This is the package.yaml and CSV file. And then inside this fault, we have an engine.yaml, fault.yaml, and CSV file. So these three files also present here. Engine.yaml, this is fault.yaml equivalent, and we have a CSV file also. So you can copy paste these files into the charts, and then you can push that chart to the GitHub. So I have already pushed this chart to the GitHub. So this chart is present here. And once the chart is pushed to the Chaos Hub, then we can connect a Chaos Hub from the Chaos Center. So we can create a new Chaos Hub. Let's say I'm using, it's a BYOC, which is bring your own chaos. And then you can copy the repository link. So we are using a HTTPS URL of the repository. And then you can provide a branch name. So I'm using BYOC branch here. And then it supports a multiple VCS types. So I'm using GitHub here. And then we can connect it. Yeah, so it is in connected state. So we can also open. So we can see there is only a single fault. So this is the same fault which we just created, pod CPU stress. And then you can go to the chaos experiment section, and then you can use the same hub to create a new experiments. So I have already have an infrastructure. So infrastructure is where our execution plane is running. So whatever the Kubernetes cluster we wanted to target, we can install a infrastructure on that cluster, and then it will discover all the services which are present on that cluster. So I already have an infrastructure which is running on my Kubernetes cluster. So I'm selecting that infrastructure. And we have multiple options here. So I'm using a blank canvas, and then I'm selecting a fault from hub. So first step, I can select a fault from hub. So I'm using a pod CPU stress fault. And then I need to select the target application which I wanted to target. So it's kindest deployment, namespace. So it is doing the discovery based on my execution plane. So it's running in a Litmus namespace. And I can use a simple Nginx application. So it is listing all the label of all the applications which are present in Litmus namespace. Then I can provide a envs here. So I'm running the chaos for the 120 seconds, and we can provide a chaos inject and revert command here. So I'm using a MD5 sum command which will run which will inject a CPU stress, and then I'm reverting it. And then we have a probes, so you can verify your hypothesis also. You can perform some health check and all those SLO validation you can perform. So as part of probe, I'm validating the target application is running or not in the before the test and after the test. So it is Nginx health check. So I am adding that probe in the edge mode, which is start of test and also end of test. And then I'm running this experiment. And I have also set up the Grafana for this, so which is showing the CPU stress. So right now there is no fault, and it's almost consuming a 0 milli CPU. So that's why we are seeing the value is 0. And so it started the fault. So once the fault chaos will be injected, you will see some CPU spike here. Yeah, I mean, it will take a while. So, I mean, do you have any questions in the meantime? Yeah.
So, this chaos, whatever we have added right now, these are local, a specific someone who has created this hub in their system. Global is only 51, which by default comes.
Correct, yes.
And if somebody wants to put into something to the global, then there is a process, or?
Yeah, so there is a LitmusChaos chart repo from where the default hub is created. So you can raise a PR there, and then once the PR got merged, it will list there.
Okay, got it. And apart from that, anybody have this hub locally in their system, they will get this 5051, whatever the predefined chaos is already there.
Correct. So it's based on the, let's say you can create a fork out of the default repo, LitmusChaos chart.
Yeah.
And then you can add your own fault also. So 51 is there, plus if you wanted to add one more from your side, then it will become 52, and then you can use it.
Got it. Thank you.
Okay.
I had a question around how the faults are injected. So here you saw that you added MD5 as a command yourself, right, to make the CPU spike. For stuff that is not really easy to do on our own. For example, let's say I want to check a disk stall issue or a disk failure issue. There really is no command for me to run that will cause the disk to stall. So how does that happen? Is this part of the 51 that is already there? How is that implemented?
Yes.
Or how
so
do you do that?
All these, if you see this here, let me open the ChaosHub. So you will find let's say Kubernetes specific. So we have a pod delete, container kill, CPU stress, network loss. Also the disk fill is there, which is filling your ephemeral storage. So we have covered almost all type of faults. So this is, I use a sample like CPU stress to just illustrate how you can create a sample experiment.
Right. So how is this different from the Amazon's fault injection service that they have? Is it similar? Do you tie in with that? If I, for example, use AWS instead of Kubernetes over here, and I try to simulate a disk failure, so I can use fault injection service there. That's actually what I'm doing right now in my CI. And if I try to use your system, how would that be different? Would it still use the same system?
So AWS is, you are talking about Kubernetes specific or AWS EC2 instance or ECS?
EC2 instance specifically. That I want to check what happens to my application when the disk stalls while I'm running it on AWS. The whole Kubernetes environment is running on top of that, but I want to check on the absolute down level what happens if EC2 crashes. A disk on EC2 crashes.
Got it. Yeah. So if you are talking about only EC2 specific, then of course you can use that like Amazon specific or this one. Like under the hood, they are using all are using the same way, but it's all about variety. So let's say in AWS, you will see only AWS specific fault only, but it contain cross infra. It contain like if you are talking about cloud, it contain AWS, Azure, VMware, GCP, everything. Also for Kubernetes, we have a lot of faults, right? If you see. It's like more than 20 to 30 faults we have for Kubernetes
so
on.
I can use AWS injections as well through your system. That basically means that if I come here, I can
that's
just
why
do
BYOC is there.
services.
So you can use any fault. Right. Even you can use a AWS specific fault as well.
Thank you so much.
Yeah, we have, I think, AWS SSM also we have integrated. So you can use AWS SSM through our thing. We can orchestrate that as well.
I have one question. Is it just application level, or we can also like test it on an infrastructure level? For example, if I want to like stress test a GPU machine, so is that possible in Chaos?
Correct. Yeah, I mean, like in this example, we were just talking about only a application-specific pod and all, but it can be a node level, it can be at a VM level as well. So you can cover everything, even disk. You can, detach and attach disk. Also, you can do a network loss at the node level as well. I mean, all the variety of faults we have.
Okay. Is there any like predefined fault for testing infrastructure stresses?
Yeah. So can you explain the scenario?
For example, like I have a VM or a Kubernetes cluster that has a GPU attached to it, and I want to stress test that. Like apart from running a full-fledged compute-intensive application, I just want to stress test that that GPU is actually able to handle that stress, and will it be able to like run my application which I wanted to run at that level.
Got it. So if that VM is a part of Kubernetes, then of course we have a node memory and node CPU as well. So you can use that. And if it is let's say normal EC2, then EC2 specific fault also we have. So it's based on like if it is EKS, then of course you can use node or EC2 base. If it is EC2, then you need to use a VM specific. You can't use Kubernetes specific faults.
Just to add on that, we also have the infra chaos label in the hub. So everything which is infra specific chaos will be labeled with the infra label.
It's high blast radius, you can say.
Got it. Thank you.
Yeah. So I think our Grafana, you can see the metrics. So it's an average, so that's why you can see the spike, even the red regions. I mean, after the red region is because it's an average value. But yeah, I mean, you can see once within the red region, the CPU spike and then it's dropped down. So yeah, I mean, that's the observability of the CPU hog. So we verify by that. Yeah. So any other questions or?
Thank you. I'm trying to figure out, let's assume I have something specific set of chaos. I'm designed myself. So how the whole step I can define? Is there a specific type of language or the format you guys have where we have to define, okay, let's assume I can do stressing with the same time putting something. I'm just giving an example, like lots of thing, like what are those steps, how those steps we can follow to create our own chaos. These are fine, this I have understand, you have some specific Kubernetes in the cloud wise, but something more complex than this, or maybe simpler but a different total like utilization, something I want to try. How I can define the steps? Is it difficult, it is specific to language, or is it some kind of a format you guys are providing right now? So how easy or how difficult it is to define a new chaos?
Got it. So first part is like, let's say if you wanted to create your own full, first part is the what part, right?
Yeah.
So what exactly you wanted to test. So based on your problem statement, of course, you need to construct the steps, right? I'm not talking about language specific. Let's say I'm talking about the steps or pseudocode kind of thing.
Yeah.
Let's say I wanted to, let's say stress or anything or whatever you want to do. First, you should have a problem statement.
Yeah.
And then in the SDK, we are orchestrating the experiment. The exact business logic, of course, you need to write.
Okay.
Let's say we have a helper model. In helper, you can create your own helper. So because this is a microservices based, so it's language independent.
Okay.
The orchestration is, of course, based on SDK. Let's say we have a Python SDK. We have an Ansible SDK. We have a Golang SDK.
Okay.
So you can use a SDK to run the orchestration. But if, let's say, you don't want to use Golang, you want to use your specific language, then you can create your own helper in that specific language. You can Dockerize it, and then you can use that image as a lib image, and then you can run it.
Got it.
So
And
because
it
it's a microservice based, so I mean, it's language independent.
And it can communicate to API server or anything, the Kubernetes APIs.
Correct. You can use the Kubernetes client in your own language.
Things. Okay, got it now. Thank you.
One more additional thing. We also have the concept called resilience probe, which you can use to inject ad hoc stuff on top of the chaos injection that you're doing. So anything that your experiment doesn't touch, you can do via the resilience probes. That is something is like a binary, like there are HTTP probe, CMD probe, Prometheus probe, so you can write your PromQL queries or CMD commands. Yeah.
Yeah, just one additional point. So fault is basically like you are injecting a fault, you are disrupting the system. And probe is like once you are disrupting the system, you wanted to validate few things, right? If it is healthy or not, or your few things are failing, that you can do via probe. So we have a Kubernetes probe, we have a Prometheus probe. Let's say you have a Prometheus metrics you wanted to validate. And based on that, you can attach a weightage also, and then it will give a resiliency score out of it. Yeah, I think next part Sayan will cover.
Yeah, which we just concluding now. So we'll just like to mention a few points on how you guys can contribute if you want to. So we welcome contributions, not just technical, but non-technical too. So we have a lot of areas on documentation. There are bug and feature reports. There's a discussion as well, which we can start if there's something you want to add on. And also the development of features, bug fixes, proposals, everything is encouraged. So it's not just code contribution, but if you want to add a new fault, let's say, or if you want to propose something new, you can create a proposal as well on the issues. And here are just a non-exhaustive list of the repos that you can contribute to. There's chaos charts, which Shubham already mentioned with the hub repository. There's chaos workflows. Test tools is where all the helpers for Litmus reside. Litmus UI is kind of archived now. It is the old design library of Litmus. We have Litmus Go, which is the one we're using today. And website LitmusChaos is the Litmus website, which is for UI developers. Lastly, just the cadence of the Litmus community calls that we have. So there are 2 calls that we currently run, which is the contributors and maintainers meeting, which happens on every 2nd and 4th Thursday of the month. And the other one is the community meeting, which is sort of non-technical and covers most of the roadmap items and community members, the contributions that they do. And it's more for the community, and the contributors one is more for the maintainers. So this happens on every 3rd Wednesday of the month. So we have 3 calls each month, which you're free to join. And that's all of this could be found on the website, as well as on the Slack channel. So if you're not on the Slack already, you can use this slack.k8s.io, which is the Kubernetes workspace, and you can just search the Litmus channel there and join us. So that's all for today from us. We have 2 talks, the Project Lightning talk up next tomorrow, and then the day after we have another Litmus talk on safeguarding your SLAs using Resilience Probe, which I talked about by a few other maintainers. And we also have the booth table number 5, which will be there from 11 on Thursday in the solutions showcase. So if you have any questions, feel free to join us, and we have a couple of swags which we would like to distribute to. So yeah, that's all from us. If you have any questions, we'd love to take them.
First of all, thank you to all 4 of you. It was a great session. If you have questions, we are here. I think all 4 of the speakers are here for a while. But after this talk, we'll have the lunch, so we can use that as a hallway track as well, if you want to grab your lunch and talk. I have a question. The workshop link that you shared, the first QR code, that will remain for how long if somebody wants to, let's say, try and...
We can keep that open for a little while, like 2-3 more hours, I think. That should be fine. Or to the end of today is also fine, end of today. So if you want to try that out, feel free to try that out. And then we'll sort of modify the link once after today.